Hello once again, everybody. We are doing more suffering today. I'm gonna try to keep this intro brief and quick. And hello, Pupper. The first thing we're gonna be doing is we're gonna be reading the C programming language manual 5th edition again for a bit. I'm gonna try to get another 20 pages knocked out. Try and do roughly 5% a day. Slow march, but kind of chip through it. And then after that, we'll be switching to Godot. Total stream time estimate today is about 3.5 hours, maybe close to 3 hours today. We'll see how it goes. Depends how stuff goes and all that other wonderful fun stuff. So, let me just turn this thing I'm listening to down very slightly. There we are. And then with that being said, I suppose let's just slam into it, shall we? Let's pull this up. Whoops, wrong screen. So I believe the other day we left right here on 2.5. If we can make you full screen, please, that would be epic. There we are. Yeah, I believe we started on the identifier section, and then after this, we will just carry on, slam into it. Oh, and one more friendly reminder as well is the TIDbot is working very right now. So what you can do is you can use Bang TTS to call a message, and if you call a message, I can then, well, not always I, but the bot can then be invoked, which can do things like that. Hello, Mr. Tib. So, yeah, that's that. Thank you to anyone and everyone tuning in. And, yeah, let's just jump right into the biscuits, shall we? Also, hello, Adam. You are very on time today. That is surprising. Not implying you have to be here, but you know, just it is surprising how quick on the draw you were. Didn't even manage to finish the intro. Yeah. Anyways, let's slam into it with this first chapter, which looks like it's going to be 2 pages. So that's a little bit of a stress test, but a quick burn, and then after that we can roll from there and see what's going on. So let's see. Let's see. 2.5. Oh, we'll read your message first. I have a strong prediction ability, and I don't know why. Yeah, this is a brief little side, I guess, is me and Bubs, I kind of passed this on to him, but there's this really weird thing that me and them have. I have dubbed it future vision, and they have adopted that term. And long story short is, like, what it is like, there's some really weird things where, like, I'll just bring up something, and, like, it's just like, yeah, that's weird. And then somehow that manifests in like a semi-brief amount of time. Like, for instance, I literally, the morning of one of my college classes when I was getting my design certificate done, I was literally like, you know, like, I've never seen anybody work on like a fire hydrant or like maintaining one. I wonder what that looks like. And I shit you not, that day on the ride to school, ride is in like I rode my bike to and from classes. But on the way there, I shit you not, I saw a dude, like, I'm guessing, like, what do you call it, like, bleeding a fire hydrant. Like, just at, like, 7:30 in the morning, in, like, a mall parking lot that I rode by, and it's like, what? It's weird. I get that jive, and, like, I'm not much of, like, an ooga booga person, but I definitely get semi-creeped out sometimes, I'll put it that way. But yeah, so let me just adjust a few little things real quickly, because I realize that I can do something sneaky beaky like. And then, yeah, oh, that's perfect for me. That's perfect for me. Okay, now without further ado, let's slam into the identifier section, and then I'll swing back to chat and check any messages that we have there. 2.5, identifiers. An identifier or name is a sequence of Latin capital and small letters, digits, and the underscore or low line character. An identifier must not begin with a digit, and it must not have the same spelling as a keyword. Beginning with C99, identifiers may also contain universal character names, section 2.9, and other implementation-defined multi-byte characters. Universal characters must not be used used to place a digit at the beginning of an identifier, and are further restricted to be letter-like characters and not punctuators. The exact list is provided in the C99 standard, ISO-IC 9899, 9899, colon 1999, Annex D, and in ISO-IEC TR 10176-1998. Identifier non-digit, identifier identifier non-digit, identifier digit, identifier non-digit, non-digit, universal character name, other implementation defined characters, non-digit, one of the, every letter from A to Z, and apparently an underscore, I believe. Digit, one of 0 through 9. Two identifiers are the same when they are spelled identically, including in the case of all letters. That is, the identifiers ABC and A capital BC are distinct. In addition to avoiding the spelling of keywords, a C programmer must guard against inadvertently duplicating names used in the standard libraries, either in the current standard or in the future library directions portions of the standard. Standard C further reserves all identifiers beginning with an underscore followed by either an uppercase letter or an underscore. Programmers should avoid using such identifiers. C implementations sometimes use identifiers for extensions to standard C or other internal purposes. Non-intentional internal. C89 requires implementations to permit a minimum of 31 significant characters and identifiers, and C99 raises this minimum to 63 characters. Each universal character name or multi-byte sequence is considered to be a single character for this requirement. Example. In the pre-standard implementation that limited the length of identifiers to 8 characters, the identifiers countless and countless1 would be considered the same identifier. Longer names tend to improve the program clarity and thus reduce errors. The use of underscores and mixed letter casing can make long identifiers more readable. Example 1, a very long identifier. Example 2, a very long identifier with each letter being capitalized at the start, and then a very long identifier, each word separated by an underscore. External identifiers. Those declared with storage class extern may have additional spelling restrictions. These identifiers may have been produced by some other software, such as debuggers and linkers, which may be more limited. C89 requires a minimum capacity of only 6 characters, not counting letter case. C99 raises this to 31 characters, including letter case, but allowing universal character names to be treated as 6 characters, up to /U0000 FFFF, or 10 characters, left parenthesis, /U00100000 or above, closing parenthesis. Even before C99, most implementations allowed external names of at least 31 characters. Example, when a C compiler permits long internal identifiers, but the target computer requires short external names, the preprocessor may be used to hide these short names. In the following code, an external error handling function has the short and somewhat obscure name of EH73, but the function is referred to by a more readable name, error_handler. This is done by making error_handler a preprocessor macro that expands the name EH73. #define error_handler EH73. Extern void error_handler left parenthesis right parenthesis semicolon ellipses error_handler left parenthesis double quote nil pointer error double quote right parenthesis semicolon. Some compilers permit characters other than those specified earlier to be used in identifiers. The $, left parenthesis, $, right parenthesis, is often allowed in identifiers so that programs can be accessed, can access non-special, the $sign is often allowed in identifiers so that programs can access special non-C library functions provided by some computing systems. References: define command 3.3, external names 4.2.9, keywords 2.6, multi-byte sequence 2.1.5, reserve library identifiers 10.1.1, universal character name 2.9. 2.5 done. Okay. Let us just quickly highlight the next section that we're on. And let's see. I feel like making a music tracker in C++. I don't know why. Stream flows, what did I do? I just moved some windows to the side. I don't think anything could go wrong. How could I make real-time audio output though? As far as I'm aware, audio input and output is basically just sending an array of just data constantly to an I/O device. So I think, as far as I'm aware, it's basically something similar to port, like not port forwarding, but port listening, whatever it is, like port binding, and basically just like sending a stream of like data through that. That's a little bit that I know, though. That's what I remember some dude doing, but I have no recollection. So that's very fun. So yeah, I mean, hey, let's just carry on, I suppose. Whoop, there goes that. Let's see. Would I need to import something though? Oh yeah, you definitely need standard I/O or something. You would need like probably like standard I/O, and then probably, I would imagine, depending on the thing, probably like some USB driver that you need to like interface with, would be my guess. And then from there, I don't know what. I'm not super experienced in it. I just know that most audio is handled as like a stream of arrays, basically, that are processed. So that's all I know. Let's see, that's another big chapter. Yeah, okay, it's okay sized. Let's see. Keywords. The identifiers listed in table 2-4 are the keywords in standard C and must not be used or as ordinary identifiers. They can be used as macro names since all preprocessors occur before the recognition of these keywords. The keywords _bool, comma, _complex, comma, _imaginary, comma, inline, and restrict are new to C99. Table 2-4, keywords in C99. I'm going to take a screenshot of this just for future reference. Actually, let's just highlight the whole damn table. I'm joking. I'm just gonna screenshot it for later, though, because that is good to know. List of keywords. Going left to right, top to bottom. Auto, _bool, break, case, care, _complex, const, continue, default, restrict, do, double, else, enum, extern, float, for, goto, if, _imaginary, inline, int, long, register, return, short, signed, size of, static, struct, switch, typedef, union, unassigned, void, volatile, and while. One small amendum to that list I just gave off is anything that had an underscore, the first letter is a capital, and then for whatever reason it has a it has a superscript of A afterwards. Apparently the definition's right here. Anything with the superscript A. These keywords are new in C99 and are not reserved in C++. Neat. So bool, complex, and the imaginary bool, complex, restrict, and imaginary are not reserved in C++. In addition to those listed, the identifiers ASM and Fortran are common language extensions. Programmers might wish to treat as reserved macros defined in a header, ISO 646.h, and _, bit and, bit or, compl, not, not or eq, equal. Sorry. Anytime I say equal here, it's EQ. XOR and XOR _equal. End of that abbreviation of equal. Those identifiers are reserved in C++. Example. The following code is one of the few cases in which using a macro with the same spelling as a keyword is useful. The definition allows the use of void in a program built with a non-standard compiler. Hashtag ifndef __stdc __. Hashtag define void int hashtag endif. References, underscore bool 5.1.5, C++ keywords 2.8, underscore complex 5.2.1, hashtag define, command 3.3, identifiers 2.5, hashtag if n def, command 3.5, inline 9.10, left angle bracket ISO 646.h, right angle bracket, header 11.5, restrict 4.4.6, underscore underscore stdc underscore underscore 11.3, void type specifier 5.9. Okay, there's that chunk. Let's see what the Atom had to say. I could make, let's catch up. Kind of hard not to use standard IO when writing C++, lol. Yeah, mostly. Anyways, BRB, I'm going to make this while watching a stream. I might just make it text-based. Anyways, I know how to make an audio file and play it, but that isn't real time. Yeah, because as far as I'm aware, anytime you pass something off to external hardware, it immediately goes from quote-unquote real-time to not real-time. That's why I believe you just send out the array that I was saying, and then you basically just hope that the audio device handles it, and then just kind of go from there and pray. What's going on with the pupper, huh? Huh? Pupper got something going on? Here, I'm going to highlight this just to mark the end. What's going on, Pupper? What's going on, Pupper? Huh? What's the Pupper up to, huh? What's the little man up to, huh? What's that? You wanna go for a pee-pee? Wanna go for a pee? Do you want to get some food? Do you want some Wawa? There's Wawa right there. Let's get the Wawa. Get the Wawa. It's right here. I'm trying to figure out the Pupper once. I apologize. Do you wanna go outside? Do you wanna go for a pee? Do you wanna shit your pants? Do you want to look all cute and adorable? Do you want to be a little dingus? Do you want to be a little dingus? I think he wants to be a little dingus. Oh wait, I think he wants to go for a pee. So I'm gonna go let him out for a pee. You want to go pee? You want to go for a pee? Okay. I would BRB. I apologize. I did not expect to take a break this soon, but Pupper calls. Up. Bub it up. What you come for a pee? Oh my gosh, you're sitting down? You don't want to go for a pee? Are you just hungry? Are you just a hungry monkey? Are you just a chunky little man looking for some more food, huh? You want to go get the food? You want to go get the food, huh? You want to go get the food? Go get the food. Go get the food, you little man. Go get the food, you little boy. Go get the food. Oh, good little man. What a good little bum. Look at that tuchus. Look at that meat. Look at that meat. Oh my gosh, he full of meat. He full of meat. He got that booty chunk though. He got that booty chunk. He got that booty chunk. And yes, I will be AFK because of my pupper. I will happily be AFK because of my pupper. My pupper is a good boy. I just worked out of town for like 3 days actually. So like, I'm kind of spoiling him with like extra food and stuff because like, he's been on like a little bit of a diet, recently to like thin him down a bit. So have I. I've lost at a peak, about 60 pounds, but I've currently gained a bit more. I've gained like 10 of that back because I've been like working out of town a lot and stuff, and I haven't been able to adhere to my diet. But yeah, after leaving him for like 3 days, I'm spoiling him with some food and stuff because I want him to know that I love him and he's a good boy. He deserves all the food. For now. We don't want him to get that chunk back, but you get the idea. Anyways, carrying on. So little mic tickle for the recording. This little sausage right there. Okay, there we are. Into the recording now. Or the next chapter. Small chapter. Predefined identifiers. Although not a keyword, C99 introduces the concept of predefined identifier and defines one such. __ func __. Unlike a predefined macro, a predefined identifier can follow normal block scoping rules like keywords, Predefined identifiers must not be defined by programmers. The identifier __func__ is implicitly declared by C99 implementations as if the following declaration appeared after the opening brace of each function definition. Example, static const char __func__ left square bracket right square bracket equals double quote function dash name double quote colon. This identifier could be used by debugging tools to print out the name of the enclosing function, as in if left parenthesis failed right parenthesis printf left parenthesis double quote function %s failed \n double quote comma __func__ right parenthesis colon or semicolon. Shoot. When translating C programs for targets with tight memory constraints, C implementations will have to be careful about getting rid of these strings if they are not needed at runtime. References: function definition 9.1, predefined macro 3.3.4, scope 4.2.1. Whoa! Is this another small chapter? This one's me. Am I missing something? Oh, I'm gonna have to lock in for this next one. Holy shiza. Okay. Yeah, this next chunk is going to be, as the kids might say, girthy as heck. So, let me check one small thing real quickly, and then after I check the small thing, then we will dive right into it. Doop-a-doop. Let's see. Doop-a-doop. Doop-a-doop. And one more little tiny thing. And, okay, there's that. Actually, wait, no, that isn't that, because that didn't update. There we are. Okay, alas, carrying on. 2.7 constants. The lexical class of constants includes 4 different kinds of constants: integers, floating point numbers, characters, and strings. Constant, integer dash constant, floating dash constant, character dash constant, string dash constant. Such tokens are called literals in other languages, so to distinguish them from objects whose values are constant, i.e. not changing, but that do not need to be lexically distinct from classes. An example of the latter objects in C is enumeration constants, which belong in the lexical class of identifiers. In this book, we use the traditional C terminology of constant for both cases. Every constant is characterized by a value and type. The format of the various kinds of constants are described in the following sections. References: character constant 2.7.3, enumeration constants 5.5, floating point constant 2.7.2, integer constant 2.7.1, string constant 2.7.4, tokens 2.3, value 7.3. Okay. One small reprieve for the big, chunky as heck section. So, let's see. This is going to be a 3-page, 4-page almost blitz. Okay, let's suffer. I'm gonna take a little small sippy before I start. Yes. Integer constants may be specified in a decimal, octal, or hexadecimal notation. Integer dash constant, decimal dash constant, integer dash suffix, subscript opt. Octal dash constant, integer dash suffix, subscript opt. Hexadecimal dash constant, integer dash suffix, subscript opt. Decimal constant, colon, non-zero dash digit, decimal dash constant, digit, octagonal dash constant, colon, 0, octagonal dash constant, octagonal dash digit, hexadecimal dash constant, colon, 0x hex dash digit, 0x hex dash digit, hexadecimal dash constant, hex dash digit, digit, colon, 1 of 0 through 9, non-zero dash digit, colon, 1 of 1 through 9, octal digit, 1 of 0 through 7, hex dash digit, colon, 1 of 0 through 9, then A through F. And then lowercase a through F. It has both counted upper and lowercase. Integer dash suffix, colon, long dash suffix, unassigned dash suffix, subscript opt, long dash suffix, unassigned dash suffix, subscript opt, C99, unassigned dash suffix, long dash suffix, subscript opt, unsigned dash suffix, long dash suffix, subscript opt, C99, long dash suffix, colon, 1 of L, capital L, long suffix, colon, 1 of C99, LL, capital L, unassigned dash suffix, colon, 1 of U, capital U. These are the rules for determining the radix of an integer constant, colon. 1. If the integer constant begins with the letters 0x or 0 capital X, then it is a hexadecimal notation with the characters A through F or capital A through capital F representing 10 through 15. Otherwise, if it begins with the digit 0, then it is octal notation. Otherwise, it is decimal notation. An integer constant may be immediately followed by suffix letters to designate a minimum size for its type. Letters L or capital L indicate a constant of type long. Letters LL or capital L indicate a constant of type long, left parenthesis, C99, left parenthesis. Letters U or capital U indicate an unsigned type, left parenthesis, int, comma, long, comma, or long, right parenthesis. The unsigned suffix may be combined with the long or long suffix in any order. The lowercase letter 1 can easily be confused with the digit 1 and should be avoided in suffixes. I think I said this again, but I'm going to restate it just in case I said it stupid. The lowercase letter L can easily be confused with the digit 1 and should be avoided in suffixes. The value of an integer constant is always non-negative in the absence of overflow. If there is a preceding minus sign, it is taken to be a unary operator applied to the constant, not part of the constant. The actual type of an integer constant depends on its size, radix, suffix letters, and type representation decisions made by the C implementation. The rules for determining the type are complicated and they are different in the pre-standard C, C89, and C99. All the rules are shown in table 2-5. If the value of an integer constant exceeds the largest integer representable in the last type within its group in table 2-5, the result is undefined. In C99, an implementation may instead assign an extended integer type to these large constants. Following the signedness conventions in the table, left parenthesis, if all the standard choices are signed, then the extended type must be signed. If all are unsigned, then the extended type must be signed. Otherwise, both signed and unsigned are acceptable. In right parenthesis, in C89, information about representation of integer types is provided in the header file limits.h. In C99, the files standard int.h and int_types.h contain additional information. To illustrate some subtleties of integer constants, assume that type int uses a 16-bit 2-complement representation, type long uses a 32-bit 2-complement representation, and type long uses a 64-bit 2-complement representation. We list in table 2-6 some interesting integer constants, their true mathematical values, their types conventional and under the C standard rules, and their actual C representations used to store the constant. An interesting point to note from this table is that the integers in the range 2 to the power of 15 through 2 to the power of 16 minus 1 have positive values when written as a decimal, constants but negative values when an octal or hexadecimal constants, left parenthesis, and cast type int, right parenthesis. Despite these anomalies, a programmer is rarely surprised by the values of integer constants because the representation of the constants is the same even though the type is in the question. C99 provides some portable control over the size and type of integer constants with the macros int n_c, uint in_c, int max_c, and uint max_c defined in standard int.h. Example: if type long has a 32-bit 2-complement representation, the following program determines the rules in effect. To break the script for a second, this is going to be a long table, so I'm going to read it row by row, left to right, top to bottom, but I'll be doing my best to reread the table header each time. So that way it's not confusing because there is a lot of data here. So I apologize. Constant dd ellipses d, original C superscript a, int long, C89 superscript a, int long, unsigned long, C99 superscript a comma b, int long, table header constant 0dd ellipses d, 0xdd ellipses d. Oops, accidentally jumped pages, my apologies. Original C superscript a, unsigned long, C89 superscript a, int unsigned long, unsigned long, C99 a superscript a comma b, int unsigned long, unsigned long, unsigned long. Table header constant dd ellipses d, capital U or lowercase u. I'm just gonna say u. Sorry, apologies. 0dd ellipses d u, 0xdd ellipses d u. Original C superscript a, not applicable. C89 superscript a, unsigned long. C99 superscript a comma b, unsigned int, unsigned long. Table header constant dd ellipses d l long, original C a or superscript a, long, C89 superscript a, unsigned, long, unsigned long, C99 superscript a, comma b, long, unsigned long, unsigned long. I think that was correct. I apologize if it was wrong. dd ellipses d, ul, table header constant dd ellipses d ul, 0 dd ellipses d ul, 0x dd ellipses ul, original C superscript A, not applicable, C89 superscript A, unsigned long, C99 superscript A comma B, long, unsigned long, long long, unsigned long long, dd ellipses D, ul, 0 dd, I believe I just read that part actually. I think I just read that part. Yes, I apologize. Sorry. dd ellipses D, ll, original C, superscript A, not applicable. C89, superscript A, not applicable. C99, A comma, superscript A comma B, unsigned long, unsigned long long. Table header constant, 0 dd, ellipses D, ll, 0x dd, ellipses D, ll, original C, superscript A, not applicable. C89, superscript A, not applicable. C99, superscript A comma B, long long, unsigned long long. dd ellipses, or sorry, table header constant, dd ellipses D, ull, 0 dd ellipses D, ull, 0x dd ellipses D, ull, original C superscript A, not applicable. C89 superscript A, not applicable. C99 superscript A comma B, unassigned long long. Superscript A. The chosen type is the first one of the appropriate group that can represent the value of the constant without overflow. B. If none of the listed types are large enough, an extended type may be used if it is available. I think I said superscript B there. If not, then I apologize. Hashtag define, capital K, 0x f f f f f f. Is that 8 Fs? I apologize. Sorry, I had a lost hard time reading there. Dyslexia, fun. Comment, -1 in 32, or sorry, -1 in 32-bit to's compl. End comment. Hashtag include, left angle bracket, standard IO dot H, right angle bracket. Int main left right parenthesis, left curly bracket, if left parenthesis 0 less than K, right parenthesis, if F, left parenthesis, double quote, K is unsigned, left parenthesis, standard C, right parenthesis, \n, double quote, right parenthesis, semicolon, else, printf, left parenthesis, double quote, K is signed, left parenthesis, traditional C, right parenthesis, \n, double quote, right parenthesis, semicolon, return 0, semicolon, right curly bracket. References. Conversions of an integer type 6.2.3, extended integer types 5.1.4, integer types 5.1, int max underscore C 21.5, int n underscore C 21.3, limits.h 5.1.1, overflow 7.2.2, standard int.h ch21, urinary minus operator 7.5.3, unsigned integers 5.1.2. End of references. 28, or page 28. I don't know, I'm counting the page number now. Table 2-6, assignment of types to integer constants. C constant notation. Sorry, I'm gonna preface this again. This is a 5-column table with however many rows. I'm going to do my best to do the pattern again of table header value, table header value, table header value the whole way down, and then redeclare the table header each time I like reach the end of the table and like restart to go one row down from where I was at, like the last table. And I apologize, this is very fun to do. Table header, constant C constant notation, 0. True value, 0. Traditional type, int. Standard C type, int. Actual representation, 0. Table header, C constant notation, 32767. True value, 2 to the power of 15 minus 1. Traditional type, int. Standard C type, int. Actual representation, 0x7fff. C constant notation, 077777. 2 to the power of 15 minus 1. Or sorry, true value, 2 to the power of 15 minus 1. Traditional type, unsigned. Standard C type, int. Actual representation, 0x7fff. Table header, C constant notation, 32768. True value, 2 to the power of 15. Traditional type, long. Standard C type, long. Actual representation, 0x00008000. Table header, C constant notation, 01000000. True value, 2 to the power of 15. Traditional type, unsigned. Standard C type, unsigned. Actual representation, 0x8000. Table header, C constant notation, 65535. True value, 2 to the power of 16 minus 1. Traditional type, long. Standard C type, long. Actual representation, 0x0000FFFF. Table header, C constant notation, 0xFFFF. True value, 2 to the power of 16 minus 1. Traditional type, unsigned. Standard C type, unsigned. Actual representation, 0xFFFF. 65536. Or sorry. Table header, C constant notation, 65536. True value, 2 to the power of 16. Traditional type, long. Standard type, long. Actual representation, 0x00010000. Table header, C constant notation, 214748367. True value, 2 to the power of 31 minus 1. Traditional type, long. Standard C type, long. Actual representation, 0x7FFFFFF. 0x7FF. Or sorry. Table header, C constant notation, 0x7FFFFF. Got it. True value, 2 to the power of 31 minus 1. Traditional type, long. Standard C type, long. Actual representation, 0xF. Sorry. Actual representation, 0x7FFFFFF. 214748364. True value, 2 to the power 31. Traditional type, long superscript A. Standard C type, unsigned long. C99, long. Actual representation, 0x8000000. C constant notation, 0x8000000. True value, 2 to the power 31. Traditional type, long superscript A. Standard C type, unsigned long. Actual representation, 0x08000000. Table header, C constant notation, 42949672995. True value, 2 to the power 32 minus 1. Traditional type, long superscript A. Standard C type, unsigned long. C99, colon, long long. Actual representation, 0x f f f f f f f. I think there's one more F there. Yeah, 8 Fs. C99, long long. Actual representation, 0x 0000000 f f f f f f f f 0 f f f f f f f f 2 to the power 32 minus 1. Shoot. C constant notation, 0x f times 8. True value, 2 to the power 32 minus 1. Traditional type, long, superscript A. Standard C type, unsigned long, 0x 8f's. C99, or sorry, standard C type, C99, long long. I feel like I made a mistake here. But I feel like I lost my place. I think I lost my place. I feel like I lost my place. Shoot, where was I? Where was I? I completely lost my place. I pulled one of those hard blanks. Oops. My pupper distracted me. I blame him. He's so distracting. What are you doing, pupper? Do you want to go for a pee now? Do you actually want to go for a pee now? What do you want, huh? What do you want, baby? What do you want, pupper? What you up to, huh? You go for a pee? No? Goes and hides again. Oh, you little dingus. Okay. I believe I was at this point here, so I'll just carry on from here. If not, I'm sorry, you can pause the video and just look at the table. Surprised you haven't done that yet. Table header, C constant notation, 42949672995. True value, 2 to the power of 32 minus 1. Traditional type, long superscript A. Standard C type, unsigned long. C99, colon, long long. Actual representation, 0x f f f f f f f f. C99, colon, or sorry, standard C type, C99, long long. Actual representation, 0x 0000000 f f f f f f f f 0x 8f's to the power 32 minus 1, long superscript A. Unsigned long, 0x followed by 8f's. I think I butchered that. I'm gonna keep rolling. Sorry, I'm dyslexia's kicking overboard right now. 42949672996. True. Oh my gosh. C constant notation. Last number. True value, 2 to the power 32. Traditional type, undefined. Standard C type, undefined. Actual representation, 0x0. Standard C type, C99, long long. Actual representation, 0x0000001000000000. Table header, C constant notation, 0x100000000. True value, 2 to the power 32. Traditional type, undefined. Standard C type, undefined. C99, long long. Actual representation, standard C type. Standard C type, undefined. Actual representation, 0x0. Standard C type, C99, long long. Actual representation 0x000000100000000. Holy crap, that was hard to get through. I think I'm going to stop reading tables like that and then just kind of parse them, because I have no idea how I'm going to read stuff like that in the future, because holy crap, that's a pain in the ass. Please come home. You've done nothing other than read manuals for the past week. The kids miss you. Fuck you. Knowledge in my brain. I need it. I also want to die. I wish for death. Oh, sorry. I wish for death. I wish to be unalived. Because holy crap, this is an actual pain in the ass. Okay. Oh, sorry. I forgot to read from the previous table. Superscript A, the type cannot represent the value exactly. Okay. 2.7. Alright, let's see how long this next section is. Oh, it's another long section, but we can get through this. We can do this. We can do this. We can do this. We can do this. Okay. Floating point constants may be written with a decimal point, a signed exponent, or both. Standard C allows suffix letter, left parenthesis, floating suffix, right parenthesis, to determine constants of types float and long double. Without a suffix, the type of the constant is a double. Colon.
Hopper, what do you want, huh? What can I do for you? What do you want, huh? You have water. You had your food. Do you want to go pee? Do you want to go for a pee? What does the baby want, huh? Huh? What can I do for you? What can I do for the precious little man? You want to go outside? You want to go outside for a pee? I think he wants to go outside for a pee. You want to go outside for a pee? Come on, let's go for a pee. Let's go for a pee. Come on. Come on, let's go pee. Let's go pee. 1 second, I need to let the pupper out for a pee. Come on, let's go. Let's go. Come on, pee pee. Come on, it's pee pee time. It's time to go for a pee pee. It's time to go for a pee pee. Come on. Come on, let's go. Let's go. Come on. Come on. What are you doing? Wait. What do you want? There's water here. What's this? What's this? Come get it. Come on. What's wrong with you? Is somebody just needy for attention? You know I do this. I gave you a walk earlier. I gave you so much attention earlier today too. We hung out for so long and I gave you so much attention. Didn't I? Didn't I? You want to come on the bed? You want to come on up under the bed? Here, I will help you. Look, come here. Come here. Come on. Come on. Up. Up. Up, up, up. Come on. Come on. I don't know what you want. You aren't talking to me. You weren't talking to me. Come on. Come on. Come on up. Come on up, Pupper. Up, up, up. Up, up, up. Oh, there's my good boy. Whoa. There you are. Big comfy bed. Big comfy bed. Come on. Come relax. Oh, there is my little villain. Oh, my good boy. Oh, my good little man. What are you doing? What's going on with you, huh? What's going on with you? Huh? Are you doing good? Are you doing okay? Are you doing okay? You got little things stuck in your phone. You got little things stuck in your phone. There you are, Pops. Mwah. You're a good boy. You are a good boy.
Okay, sitting back down. I have returned. Room light back on. We're vibing. Apologies, the pupper was being weird. He's on the bed. He seems okay now. Hello, Alan. What is this video? Just popped in your feed. I am currently, unironically, reading the C Manual 5th edition. We're on page 40. It says page 46, but that is not accurate. We're on this chapter 2.7.2, which is page 28 out of, I think it was like 500. Yeah, just over 500. Probably about 500 once you cut the fluff and all that. So yeah, I'm reading about 20 pages a day on stream, and then after I read about 20 pages a day on stream, then I switch over to doing Godot development. So 2 reasons I would possibly read this. First reason is funny meme lol. Read the book. Second reason is I figured, hey, why not do it, and then somebody can use it as like an audiobook thing when they're like working or whatever. The third reason is that I have mainly personally played with higher level languages. Like I've done a good chunk of stuff in JavaScript. I have played around with stuff like C# and GDScript quite a bit too, but I've never really played with anything low level. So my sort of intent is that you hear a lot of low-level programmers be like, oh, just learn C, lol. So this is my hardcore run at it where I wish to slam my head on the table over and over again until hopefully something good comes out of it. So, alas, I'm reading it. Normally these sections take about 2 hours, give or take. And then we normally spend about 2 hours doing something else thereafter. So, yeah, we're currently about hour 1 of 2 of that pain. And then after we do that, then we will go on to suffer. This is a very hardcore way to learn C. Yeah, so I've heard. My sort of thing is like I will put out as like an asterisk that I have coded like some CLI stuff in C and whatever. But a lot of it is like I am a person who has a certain type of tism, who really likes the details, and whenever details for me are obscured, there is a gremlin in the back of my brain that wants to scream and wishes to make me do things that I do not wish to do. So as it currently is, this is the way of satiating the gremlin as well. So I guess there's a fourth reason, I suppose. So all levels of suffering that I get to deal with because I am me and I am stupid. So my intent is to effectively read this entire manual, and then anytime henceforth where I have an issue with C, I should be able to completely blame whatever part of C it is instead of my thing. I just silenced the gremlin. Yeah, the issue is that my gremlin likes that, so it kind of gets all weird and freaky, and it's just kind of like, I don't want to deal with that shit. most of them are like, oh no, please stop, and then mine just like, do it more. So I don't know, it's stupid. Let the invasive thoughts win. Kinky gremlin? I think so. I think it's a real big fan of the GNU image manipulation program. But so yeah, so what my loose pace is right now is I basically read about a chapter, whatever that chapter is. So in this case, I'll be reading from here to this point here in a second. So that'll be about 2 pages, kind of letting the dyslexia cool down, and then I'm gonna slam back into it and then attempt to read it. Thankfully, this doesn't seem to be nearly as bad, because before I was trying to read this table for people who like were unable to watch, and like, holy shit, that was tough. So yes, that is my current point of suffering. I think at this uno momento, I am probably going to slam back into it, and then I will shuffle back to chat once I'm done these like next 2 pages. So alas, here we go. 2.7.2 floating point constraints. Floating point constraints may be written with a decimal point, a signed exponent, or both. Standard C allows a suffix letter, left parenthesis, floating point, suffix, right parenthesis, to determine constants of types float and long double. Without a suffix, the type of the constant is double. Colon. Floating constant, colon, decimal dash floating dash constant, hexadecimal dash floating dash constant, C99, decimal dash floating dash constant, colon, digit dash sequence, exponent, floating dash suffix, subscript opt, dotted dash digits, exponent, a subscript opt, floating dash suffix, subscript opt, digit dash sequence, colon, digit dash sequence, digit, dotted dash digits, colon, digit dash sequence, dot, digit dash sequence, dot, digit dash sequence, dot, digit dash sequence, digit, colon, 1 of 0 through 9, exponent, colon, e, sign dash part, subscript opt, digit dash sequence, capital E, sign dash part, subscript opt, digit dash sequence, sign dash part, colon, 1 of, plus, minus, floating dash suffix, colon, 1 of, F, L, capital L. I see your little thing. I'll get to that in just a second, Alan. Just trying to go through the chapter clean. The value of a floating point constant is always non-negative in the absence of overflow. If there is a preceding minus sign, it is taken to be a unary operator applied to the constant, not part of the constant. If the floating point constant cannot be represented exactly, the implementation may choose the nearest representable value, v, or the larger or smaller representative value around v. If the magnitude of the floating point constant is too great or too small to be represented, then the result is unpredictable. Some compilers will warn the programmer of the problem, but most will silently substitute some other value that can be processed or represented. In standard C, the floating point limits are recorded in the header file float.h. Special floating dash point constraints such as infinity and nan, N-A-N, left parenthesis, not a number, right parenthesis, are defined in math.h. In C99, a complex floating point constant is written as a floating point constant expression involving the imaginary constant underscore complex underscore I, left parenthesis, or I, right parenthesis, defined in complex.h. Example. These are valid decimal floating point constants. 0, period, comma, 3E1, comma, 3.14159, comma, dot 0, comma, 1.0e minus 3, comma, 1e minus 3, comma, 1.0, comma, .00034, comma, 2e plus 9. These additional floating point constants are valid syntax in C, colon, 1.0f, comma, 1.0e67, capital L, comma, 0e1l, period. I should specify that basically all of these are using lowercase e's, except for the example of 0e minus 3, which the e is capital, and 0 capital E, 1 capital L. I apologize. An example of C99 complex constants is 1.0 plus 1.0 asterisk capital I, left parenthesis, if complex.h has been included, right parenthesis, period. C99 permits floating point constants to be expressed in hexadecimal notation. Previous versions of C had only decimal floating point constants. The hexadecimal format uses the letter P to separate the fraction from the exponent because the consumer letter E could be confused with the hexadecimal digit. The binary exponent is a signed decimal number that represents a power of 2, left parenthesis, not a power of 10 as the case of decimal floating point constraints, nor a power of 16 as one might guess, right parenthesis, period. Floating point constant, hexadecimal dash floating dash constant, colon, C99, hex dash prefix, dotted dash hex dash digits, binary dash exponent, floating dash suffix subscript opt, hex dash prefix, hex dash digit dash sequence, binary dash exponent, floating dash suffix subscript opt, hex prefix, colon, 0x, 0 capital X, dotted dash hex dash digits, colon, hex dash digit dash sequence, dot, hex dash digit dash sequence, dot, hex dash digit dot sequence, dot, hex dash digit dash sequence, hex dash digit dash sequence, colon, hex dash digit, hex dash digit dash sequence, hex dash digit, binary dash exponent, colon, p, sign dash part, subscript opt, digit dash sequence, capital P, sign part, subscript opt, digit dash sequence. It may not be possible to represent a hexadecimal floating point constant exactly if FLT underscore RADIX, left parenthesis, float.h, right parenthesis, is not equal to 2. If it is not represented exactly, the designated value must be correctly rounded to the nearest representable value. References: complex.h 23.2, doubles type 5.2, float h 5.2, overflow and underflow 7.2.2, sizes of floating point types 5.2, urinary minus operator 7.5.3. We did it, boys! Holy crap. What does opt mean? If I'm correct, opt is a, what do you call it? It's like, I don't think they actually specified here. My guess is that opt would be something akin to, like, a accessor, akin to something like, what do you call it? Like a minus sign or plus sign or something else, but I actually don't know. I don't think it's been clarified. Holy shit, C has complex numbers? It apparently does, yes. So nice and fun. I don't think it would actually be able to do complex numbers like, I don't know, what's an example? Frickin' mine go burr, but it can at the very least do scientific notations. That's neat. Well, if you like the hexadecimal multiplication and how you can manage them, I recommend the micro corruption. It's a cybersecurity challenges, but if you like low level, it's really fun. I have actually never tried it, so that actually sounds awesome. Thank you for the recommendation, the nudge, the whatever the heck you want to call it. I will actually throw it in a tab right here. So hopefully you don't destroy my computer. Let's see. Whoops, keyboard needs to turn on because of Bluetooth. Micro corruption. Micro corruption. Yep, I'm cool doing that because education is fun. Choose your next level. Neat. Okay, I will check this out at some other time because that is neat. So I'm gonna slot that in here. In fact, actually, let me do one more thing. I'm gonna do some tiny management on stream because Arc lets me do folders. So I'm just gonna do. Can I not just create a folder? I just want a new folder. There's a new folder. Let's see. Let's right click. We will rename to Godot things. Genuinely, thank you for the recommendation. Uno, dos, tres, cuatro. I did not mean to do that. Remove from split, please. Separate tab from split. There we are. Godot things go away. Nope, we need to go into the Godot things folder. Can I just minus you? There we go. And then check out later. And then we'll just drag the micro corruption thing into there because that will definitely be a fun little thing for me. Oh, there's a lot more in there as well. Neat. I'm gonna freaking drag these Godot things into here as well because those should be in there as well. Yep. I forget what that was. That was a live stream chat that I had open on a previous stream. That makes sense. So we'll do that. That is an old search that is no longer relevant, and we'll drag this back off screen to go into the void of darkness. Huh. Okay. So let's see. Is there anything else I am missing? Nope. Once again, I should probably give you credit for your awesome recommendation. Streamless, I think is how you say that. If not, then I deeply apologize, but I don't know what the heck to say. I'm bad with names. I don't know why I'm reading this. You should have seen the first episode. Holy crap, when I was trying to give credit to the authors, mouth spaghetti. Like, it was pretty much like I got stung by a bee and I was trying to speak, like, in the tongue. Like, it was just... Oh, sorry. I got stung by a bee, bit my tongue, like, 15 times, then ate, like, the most spicy food you can, like, think of, like, some, like, really intense curry or something. That was how it was. It was... I don't know why I decided to do this. Anyways, I guess I'll suffer some more with this next chapter, and then we'll carry on. Thankfully, this one's only about 2 pages, so yay. Let's see, 2.7.3. Oh, also, carrying on is one more thing for anybody who's new. I'm not sure how long you've been watching. Falm, I think is how you say it again. I try to go through a chapter in one chunk, and then I respond to chat and whatever, and take a small break after. So, I'm not ignoring anyone. It's just between chapters. It's just I have to, like, lock in. I'm just imagining me in, like, 2nd grade, like, with a book upside down, like, I am taking this in, without actually doing any of the work that's actually needed. Anyways, 2.7.3 character constants. Character constant is written by enclosing one or more characters in apostrophes. A special escape mechanism is provided to write characters or numeric values that would be inconvenient or impossible to either directly in source program. Impossible to directly enter the source program. I feel like I read that wrong. Standard C allows the character constant to be preceded by the letter capital L to specify a wide character constant. Character constant, colon, apostrophe C dash care dash sequence, apostrophe, capital L, apostrophe C dash care dash sequence, apostrophe, left parenthesis, C89, right parenthesis, C dash care dash sequence, colon, C dash care dash sequence, C dash care, colon, any source character except the apostrophe, backslash, or new line, escape dash character, universal dash character dash name, left parenthesis, C99, right parenthesis.
Popper, you wait for a second, please.
The apostrophe, backslash, and new line characters may be included in a character constraints by using escape characters. As described in section 2.7.5, it is a good idea to use escapes for any character that might not be easily readable in the source program, such as the formatting characters. C99 allows the use of universal character names in character constraints, left parenthesis, section 2.9, right parenthesis. Character constraints not represented by the letter L have type int. It is typical for such character constraints to be a simple character or escape code, left parenthesis, section 2.7.7, right parenthesis, and the value of the constant is the integer encoding of the corresponding character in the execution character set. The resulting integer value is computed as if it has been converted from an object of type char. For example, if type char were 8-bit sign type, an 8-bit sign type, the character constant apostrophe backslash 377 apostrophe would undergo sign extension, thus we would have the value -1. The value of the a character constant is implementation defined if 1. There is no corresponding character in the execution character set, 2. More than a single execution character appears in the constant, or 3. A numeric escape has a value not represented in the execution character set. Example. Here are some examples of single character constants along with their left parenthesis, decimal, right parenthesis, values under ASCII2 encoding. I'm going to read this table in the format of table header and then value going left to right, and then I'll try to redeclare when I reset by saying table header. So, row 1, table header, apostrophe A, apostrophe, value, 97, character, apostrophe, capital A, apostrophe, value, 65. Character, apostrophe, space, apostrophe, table header, that was a table header there, value, 32, character, apostrophe, question mark, apostrophe, value, 63. Character, table header, character, apostrophe, backslash, R, apostrophe, value 13, character, apostrophe backslash 0 apostrophe, value 0, table header, character 0 apostrophe double quote apostrophe, value 34, character apostrophe backslash 377 apostrophe, value 255. Table header, character, apostrophe %, apostrophe, value 37, character, apostrophe backslash 23, apostrophe, value 19. Character, apostrophe 8, apostrophe, value 56. Character, apostrophe backslash apostrophe, value 92. Standard C wide character constraints designed by the prefix letter capital L have type wchar_t, an integral type defined in the header file standarddef.h. Quick asterisk, anytime I say standard in reference to a header file, that is most likely std, and then whatever after. And then anytime I say char, that's char. I'm trying to do it like how I say it, like character. Their purpose is to allow C programmers to express characters in alphabets, left parenthesis, e.g., Japanese, right parentheses, that are too large to be represented by type char. Wide character constraints typically consist of a sequence of characters and escape codes that together form a single multi-byte character. The mapping from the multi-byte character to the corresponding wide character is implementation defined. Corresponding to the mbtowc function, which performs that conversion at runtime, if multi-byte characters use a shift state encoding, then the wide character constant must begin and end in the initial shift state. The value of a wide character constant is implementation defined if it contains more than a single wide character. Multi-character constants. Integer and wide character constants can contain a sequence of characters. After mapping that sequence to the execution character set, there may still be more than one execution character. The meaning of such a constant is implementation defined. Heck. Multi-character constants. Integer and wide character constants can be contained in a sequence of characters. After mapping that sequence to the execution character set, there may still be more than one execution character. The meaning of such a constant is implementation defined. One convention with older implementations was to express a 4-byte integer constant as a 4-character constant, such as apostrophe G capital R8T apostrophe. This usage is non-portable because the implementations may not permit it, and implementations differ in sizes of integers in their byte ordering, left parenthesis, i.e., the order in which the characters are packed into words, right parenthesis. Example. In the ASCII2 implementation with 4-byte integers and left-to-right packing, the value of apostrophe capital A, capital B, capital C, capital D apostrophe would be 41424344 subscript 16. Left parenthesis, the value of apostrophe A, capital A apostrophe is 0x41. Apostrophe capital B apostrophe is 0x42, etc. Right parenthesis. However, if the right to left packing were used, the value of apostrophe capital A, capital B, capital C, capital D apostrophe would be 44434241 subscript 16. References. ASCII2 characters app. I believe Appendix A is how it's supposed to be. Byte order 6.1.2. Character encoding 2.1. Char type 5.1.3. Escape characters 2.7.5. Formatting characters 2.1. MBTOWC family 11.7. Multi-byte characters 2.1.5. wchar_t 11.1. Okay. Let's see. Let us slam this through. Let's see what the heck there is. Why on earth are you reading it like that? This is your autism mark. Yes, correct. You were not wrong. It is very painful, but it is very true. I am trying to weaponize it, though. One of these days, I will be able to use a keyboard for my job. And then from Falm Streamless, they just like TTS IRL for real. Somewhat. I am a wonderful array of weirdness, and I think I am weird enough to the point that I am uniquely me. And that is coming from many people who have the quote unquote autism arc. My pupper here is whining, so what I'm going to do for just a brief second is we're not done reading yet, but what I'm going to do is I'm going to hide the screen capture for editing me,
And I'm gonna see what the heck this pupper needs. What the heck does this pupper need, huh? What the heck does this little pupper need?
I'm also just gonna, I'm just gonna turn this back on. I'm just gonna hit the AFK button. I'll still be kinda here. Like I'll be able to read chat and stuff. I just won't be able to like hear any TTS messages or anything.
What's this little baby want, huh? What's this little man want, huh? You're so toasty, aren't you? You okay? Is this little bum okay? What's going on with you, huh? You wanna go for a pee? You wanna go for a pee? Do you want some water? What do you want, boo? What the heck do you want, boo? What can I do for you? What can I do for you? Look at this little heckin' lump. Boy, look at this little heckin' lump.
Yes, I'm going to make sure that this heater is off, and then I'm going to open my window some because this pupper seems to be having a bad time. So I'm going to actually fast air in real quickly, get some movement going on, get some of that airflow, get some of that good vibes going. It is actually a little bit toasty in here. Okay, so hopefully that fanning did a little bit of something. Oh yeah, it took the edge off of the heat. That's nice. That's nice. Okay, I have now returned from here, and we are now vibing because yes, we are zizzity zaza. Okay, room light. Hello once again. Let's see. How do I get SFML to stop screaming all the debug info? I have no idea what SFML is. I'm going to Google that promptly because, yeah. Let's see the typing. SFML. Oh, SFML. Oh, shift isn't being recognized. SFML. SFML. Simple and fast multimedia library. SFML. Wow, this website is whoops. This website fresh out of 2008. Like man, for 2008 though, this was bumping. Like if you saw this in 2008, ooh, you were screaming. This was peak. Though that's how you also know it's like actually like a good thing, because like there's like this sort of thing where like whoops, hello Final Cut. There's a sort of thing with like software that I've noticed personally, where if you take a sort of curve, let's do something like this. Let's do this. Can I write? Yeah, okay, there we are. I noticed if you have a graph, right, and then like like this is the quality of the software, and this is like the style. It's like as style gets better, quality gets worse. Like it's just directly proportional, and that's more or less how it goes. There's like a little bump somewhere like right here, but that's basically all that happens. Where you have just this weird sort of spike there, and that's kind of it. You know what? Actually, it's basically just like the Dunning-Kruger curve, where it's just like it's like, hey, here's like dip, there's a little pit, and it gets better, and then it's like bad again, and then yeah, that's the software graph. Anyways, should I get back to the thing that we were all here for? I don't know. Maybe you should. I don't know. Let's go. Let's see. 2.7.4 string constants. Oh yes. Once again, just a reminder, I'm going to read this chapter, and then at the end of the chapter, I will look back at chat and try and catch up and do all the chatty stuff. So we will see what happens from there. Yeah, and then if anybody wants to do TTS messages, just do bang TTS at the start of your message, and I will use the TTS machine after to do TTS things, if you wish for that level of interaction. Anyways, let's see. 2.7.4 string constants. A string constant, left parenthesis, possibly empty, right parenthesis, sequence of characters enclosed in double quotes. Or sorry, is a sequence of characters enclosed in double quotes. The same escape mechanism provided for the character constants can be used to express the constants in the string. The standard C allows the string constant to be preceded by a letter capital L to specify a wide string constant. String constant, colon, double quote, S dash char dash sequence subscript opt, double quote, capital L, double quote, S dash string, S dash char dash sequence subscript opt, double quote, left parenthesis, C89, right parenthesis, S dash char dash sequence, colon, S dash char dash sequence, S dash char, colon, any source character except the double quote, comma, backslash, comma, or new line character, escape dash character, universal dash character dash name, left parenthesis, C99, right parenthesis. The double quote, backslash, and new line characters may be included in character constants by using the escape characters as described in section 2.7.5. It is a good idea to use escapes for any character that might not be easily readable in the source program, such as the formatting characters. C99 allows the use of universal character names and string constants, left parenthesis, section 2.9, right parenthesis. Example, 5 string constants are listed next. Double quote, double quote, double quote, backslash, double quote, double quote, double quote, total expenditures, colon, space, double quote, copyright 2000, backslash, Texas Instruments, period, space, double quote, comments begin with apostrophe, / asterisk, apostrophe, dot, backslash, n, double quote. The for string is the same as copyright 2000 Texas Instruments, period, double quote. It does not contain a new line character between the 0 and the T. For each non-wide string constant of n characters, at runtime there will be a statically, I don't know why I was reading that statistically. At runtime, there will be a statically allocated block of n+1 characters, whose first n characters are the characters from the string, whose last character is the null character. Apostrophe, backslash, 0, apostrophe. This block is the value of the string constant and its type is char, left square bracket, n+1, right square bracket. Wide string constants similarly become n wide characters followed by a null wide character and have the type wchar_t, left square bracket, n+1, right square bracket. Example, the size of operator returns the size of its operand, whereas the string length function, there is strlen, left parenthesis, section 13.4, right parenthesis, returns the number of characters in a string. Therefore, size of, left parenthesis, double quote, ABCDEF, double quote, right parenthesis, is 7, not 6. And size of, left parenthesis, quote, double quote, right parenthesis, is 1, not 0. string length, left parenthesis, double quote, A, B, C, D, E, F, double quote, right parenthesis, is 6, and string length, left parenthesis, double quote, right parenthesis, is 0. I just want to reread that myself, just silently for a second, just so I can kind of interpret that. Okay. So size of is like the size plus the terminator, or like the characters plus the terminator, while string length is the actual length of characters. Got it. If a string constant appears anywhere except an argument to the address operator, ampersand, and the argument to the size of operator are the initializer of a character array, then the usual array conventions come into play. Changing the string from an array of characters to a pointer to the first character in the string. Example, the declaration of char asterisk p equals double quote A, B, C, D, E, F, double quote, colon, results in the pointer p being initialized with the address of a block of memory in which 7 characters are stored. Double dash, apostrophe A, apostrophe, comma, apostrophe B, apostrophe, comma, apostrophe C, apostrophe, comma, apostrophe D, apostrophe, comma, apostrophe E, apostrophe, comma, apostrophe F, apostrophe, comma, and apostrophe \0, apostrophe, respectively. The value of a single character string constant and the value of a character constant are quite different. The declaration int capital X equals left parenthesis int right parenthesis double quote capital A double quote colon results in capital X being initialized with left parenthesis the integer value of right parenthesis a pointer to a 2-character block of memory containing apostrophe capital A apostrophe and apostrophe \0 apostrophe left parenthesis if such a pointer can be represented as type int right parenthesis comma, but the declaration int capital Y equals left parenthesis int right parenthesis apostrophe A apostrophe comma results in capital Y being initialized with the character code for apostrophe A apostrophe left parenthesis 0x41 in the ISO 646 encoding right parenthesis. Okay. Storage for string constants. You should never attempt to modify the memory that holds a character of a string constant value since the memory may be read-only. That is, physically protected against modification. Some functions, left parenthesis, e.g. mktmp, I believe make temporary, right parenthesis, expect to be passed pointers to strings that will be modified in place. Do not pass string constants to these functions. Instead, initialize a left parenthesis non-dash constant, right parenthesis, array of characters to the constants of the string constant and pass the address of the first element of the array. Example. Consider these 3 declarations. Char p1 left square bracket right square bracket equals double quote always writable double quote semicolon char asterisk p2 equals double quote possibly not writable double quote semicolon const char p3 left right square bracket equals double quote never writable double quote semicolon comments block start standard C only end comment. The values of P1, P2, and P3 are all pointers to character arrays, but they differ in their writability. The assignment P1 left square bracket 0 right square bracket equals apostrophe X apostrophe will always work. P2 left square bracket 0 right square bracket equals apostrophe X apostrophe may work or may cause a runtime error, and P3 left square bracket 0, right square bracket equals apostrophe x apostrophe will always cause a compile time error because of the meaning of const. Do not depend on all string constants being stored in different addresses. Standard C allows implementations to use the same storage for two strings constants that contain the same characters. Example. Here is a simple program that discriminates the various implementations of strings. The assignments to string 1, left square bracket, 0, right square bracket, could cause a runtime error if string constants are allocated in read-only memory. Character asterisk string 1, comma, asterisk string 2, semicolon, int main, left right parenthesis, left curly bracket, string 1 equals double quotes, ABCD, double quotes, semicolon, string 2 equals double quotes, ABCD, double quotes, semicolon, if left parenthesis, string 1 equals string 2, right parenthesis, printf, left parenthesis, double quote, strings are shared, period, \n, double quote, right parenthesis, semicolon, else, printf, left parenthesis, double quote, strings are not shared, \n, double quote, right parenthesis, semicolon. String 1, left square bracket, 0, right square bracket, equals apostrophe 1, apostrophe, comma, comment block start, runtime error possible, comment block end, if left parenthesis, asterisk string 1 equals apostrophe 1 apostrophe, right square bracket, printf, left parenthesis, double quote, strings writable, \n, double quote, right parenthesis, semicolon, else printf, left parenthesis, double quote, strings are not writable, \n, double quote, right parenthesis, colon, return 0, colon, right squirrely bracket. From this point forward, I would like to make the declaration that if you ever hear me say new line is simply going to be my sort of verbal abbreviation for \n. So if I use the terms interchangeably or bounce back and forth or what have you, please note that they are supposed to be the exact same character. Continuation of strings. A string constant is typically written one on one. A string constant is typically written on one source program line. If a string is too long, it will fit conveniently on one line. All but the final source lines containing the string can be ended with a / character. In which case, the / and end of line characters are ignored. This allows strings constants to be written on more than one line. Some older implementations may remove leading white space characters from the continuation line, although it is incorrect to do so. I'm just gonna highlight that, don't mind me. Standard C automatically concatenates adjacent string constants and adjacent wide string constants, placing a single null character at the end of the last string. Therefore, an alternative to using the / continuation mechanism in standard C programs is to break the long string into separate strings. In C99, a wide string and a normal string constant can also be concatenated this way, resulting in a wide string constant. In C89, this was not allowed. Example. The string initializing S1 is acceptable to standard and pre-standard C compilers, but the string initializing S2 is allowed only in standard C. Colon. Char S1 left right square bracket equals double quote, this string is ACC / EPTABLE to all C compilers, double quote, semicolon. Char S2 left right square bracket equals double quote, this string is permissible, space, double quote, new line, double quote, in standard C, period, double quote, comma. That new line character is in the editor, not in the string, for clarification. A new line character, left parenthesis, i.e. the end of line in the execution character set, right parenthesis, may be inserted into a string by putting the escape sequence, new line, or \n, in the string constant. This should not be confused with the line continuation written within a string constant. Wide strings. A string constant prefixed by the letter capital L is a standard C wide string constant and is of type double quote array of w-char underscore t double quote. It represents a sequence of wide characters from an external execution character set, such as might be used in a language like Japanese. The characters in wide string constants are multi-byte character string, or a multi-byte character string, which is mapped to a sequence of wide characters in an implementation defined manner. Left parenthesis, the MBSTOWCS function performs a similar function at runtime. Right parenthesis. If multi-byte characters use a shift state encoding, the wide string constant must start and end with the initial shift state. References. Array types 5.4, const type specifier 4.4.4, versions from array types 6.2.7, escape characters 2.7.5, initializers 4.6, MBSTOWCS facility, or facility, no, this facility, 11.8, MKTMP, also known as make temp, or make temporary, facility 15.16, multi-byte characters 2.1.5, pointer types 5.3, preprocessor lexical conventions 3.2, size of operator 7.5.2, string length facility 13.4, white space characters 2.1, usual urinary conventions 6.3.3, wchar underscore t 11.1, universal character names 2.9. Chapter done. Or subchapter, whatever. Shut up, man. You mean you. We have done it. Oh, and this next chapter's kind of short. Yeah! That's what I call a win. Holy crap. Okay. Y'all doing good in chat? Y'all having a good time? The pupper is staring at me like they want something.
You wanna go for a pee now, finally? What's going on with you, huh? What's going on with you? Every time they look at me, they look so ashamed like they did something wrong. What's going on?
Now is a bad day to wear a green shirt with my crop top.
What are you doing, huh? What are you doing, Mr. Man? Huh? 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 What are you doing? What are you doing, Mr. Man? Huh? Ha 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 ha. Oh, look at this little noodle. Okay, I'm gonna get back to reading. Is that okay with you? You had your food, you had your water. You want more food? Are you fat? Oh, you want more food. You always want more food. What's going on? You wanna go to the bathroom? You wanna go inside? You wanna go inside? You are just a little nerd. You want attention and you want it to be freezing in here because you have fur. I am not falling for that. I'm not falling for those sweet eyes. Those sweet, beautiful baby puppy eyes. Lick, lick, lick. What are you sniffing my finger for, huh? I was trying to pet you and you sniffed my finger. How rude.
Okay. Anywho. Let's see. You can actually print a character array like a string. Yeah. Pretty much what I've gone is just that a string is literally just a character array. So, at least in C, so that's neat. To be fair, I don't know how else you would do it, because anything else would be really weird. But I mean, hey, whatever works, I suppose. Let me take a chug-a-glug of some wasa. Okay. I have died, but I've also been resurrected through the power of hydration. Okay. Whoop, I do not want to highlight character, please. Let's undo that. Did I undo the highlighting up here? Nope. Okay, I don't know when I highlighted this. Can I, like, unhighlight you, please? Cool, that works. I don't know why that was highlighted, but alas, here we are. Okay, well, with chat being but a hollow echo, we will carry on with more suffering with escape characters. Okay.
What do you want, Buru? What do you want, huh? 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 What you doing? Do you have something you wish to tell the people? Or may I carry on? Am I carrying on? Okay, you little nerd. Okay, I'm gonna carry on. Have I not heard nothing from you? We had a negotiation, we had a deal.
Okay. 2.7.5 escape characters. Escape characters can be used in character and string constants to represent characters that would be awkward or impossible to enter in source programmatically directly. In the source program directly. The escape character come in two variables, double quotes, character escapes, double quotes, which can be used to represent some particular formatting and special characters, and double quote numeric escapes, double quote, which allow characters which allow a character to be specified by its numeric encoding. C99 also introduces a universal character names as escapes. Escape dash character, colon, backslash, escape dash code, universal dash character dash name, left parenthesis C99, right parenthesis, escape dash code, colon, character dash escape dash code, octal dash escape dash code, hex dash escape dash code, left parenthesis C89, right parenthesis. Character dash escape dash code, colon, one of, N, T, B, R, F, V, backslash, apostrophe, double quote, A, and question mark. C89. Octal dash escape dash code, colon, octal dash digit, 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 octal dash digit. Hex dash escape dash code, colon, X, hex dash digit, hex dash escape dash code, hex dash digit, left parenthesis C89, right parenthesis. The meaning of these escapes are discussed in the following sections. If the character following the backslash is neither an octal digit, the letter X, nor one of the character escape codes listed earlier, the result is undefined. Left parenthesis, in traditional C, the backslash was ignored. Right parenthesis. In standard C, all lowercase letters following the backslash are reserved for future language extensions. Uppercase letters may be used for implementation-specific extensions. I'm gonna highlight that little tidbit right there. There we are.
And Mr. Pupperman, I heard you doing some little bit of whining, and I hear somebody who isn't telling me what the heck they want. What can I do for you, Mr. Huh? What can I do for the Mr. Man? Here, let me highlight this real quickly. Little Mr. Man, do tell me, what might you desire? What might you be desiring, huh?
I don't know why I disabled that. I'm gonna leave it on. Here we are. Hello.
The little Mr. Man, what do you want, huh? You keep giving me little whines, but you're telling me what I can do for you. Do you want some Wawa? Do you want some food? Do you want to go to the bathroom? Do you want to go outside for a pee-pee? Do you want to go take shaisa? Do you just want some attention? Do you wish to entertain the people? Is that what you wish to do? Entertain the people?
His ears are perking. He might actually wish to entertain the people. Is that what he wishes to do?
Let us see. What are you doing, Mr. Man? What are you doing, little Mr. Man, huh? Huh? What are you up to? What are you up to, huh? What are you up to? I want to push you over, and I will give you some tummy rubs. Look at this little belly. Look at this little belly, man. Look at this. Look at all this. Look at all of this. Look at you. You're squishy. You're squishy. You are a little squishy baby man. Look at you. Look at you. Look at you. Look at all this huff. Look at all this huffer. Look at all this huffer. Look at all this man. Look at all this little man, huh? Look at all this little baby man. What are you doing? What are you up to, huh? What are you up to, huh? What can I do for you? What can I do for you? You aren't working with me, bud. You aren't working with me. You need to communicate with me. You aren't moving.
I think this little man just wants attention and nothing else.
Tisk tisk. Such an attention hog. Such an attention hogger.
I don't know. What can you do? What can you do? The answer is nothing, because we are all here bound to suffer. Yeah, is this next chapter somewhat short? Yeah, this next chapter is somewhat short. Okay, cool. We got like 4 more pages, so let us keep a slamming. Let's see. 2.7.6 character escape codes. Character escape codes are used to represent some common special characters in a fashion independent of the target computer character set. The characters that may follow the backslash and their meanings are listed in Table 2-7. Table 2-7, character escape codes. Once again, doing the format of saying table header for the first one, signifying a reset, going left to right, top to bottom in a row column orientation. Table header, escape code, A, superscript A, translation, alert, left parenthesis, e.g., bell, right parenthesis, escape code, V, translation, vertical tab, table header, escape code, B, translation, backspace, escape code, backslash, translation, backslash. Table header, escape code, F, translation, form feed, escape code, apostrophe, translation, single quote, escape code, N, translation, new line, escape code, double quotes, translation, double quote. The little thing I want to point out here is that under the escape codes is a symbol. Under the translations, it is the word definition of it, like the label of it. Table header, escape code, R, the letter R. Translation, carriage return. Escape code, question mark, superscript A. Translation, question mark. Escape code, T. Translation, horizontal tab. Superscript A means standard C edition. The code \A is typically mapped to a, quote, bell, unquote, or other audible signal on an output device. Left parenthesis, e.g., ASCII2 Control-G, whose value is 7, right parenthesis. The \, question mark is needed to obtain a question mark character in rare circumstances in which it might be mistaken as part of the trigraph. A trigraph, the trigraph. The quotation mark, left parenthesis, double quotes, right parenthesis, may appear without a preceding \, in a character, in character constants. The apostrophe, left parenthesis, apostrophe, right parenthesis, may appear without a \, in string constants. Each one of those parentheses use the symbol, not the word, or the label. Example. To show how a character escapes can be used, here's a small program that counts the number of lines, left parenthesis, automatically, the number of new line characters, right parenthesis, in the input. The function getChar returns the next input character until the end of the input is reached, at which point getChar returns a value of macro e of EOF defined in standard io.h. Hashtag include, left angle bracket, standard io.h, right angle bracket, int main left parenthesis void right parenthesis comment start, count the number of lines in the input, end comment, left curly brace, int next underscore char, semicolon, int num underscore lines equals 0, semicolon, while left parenthesis next underscore char equals get char left parenthesis right parenthesis not equals, aka bang equals, EOF all capital right parenthesis If left parenthesis next underscore char equals apostrophe backslash n apostrophe right parenthesis plus num underscore lines semicolon. Printf left parenthesis double quotes %d lines read dot backslash n double quote comma num underscore lines right parenthesis semicolon return 0 colon right squirrely bracket curly bracket. References: character constants 2.7.3, EOF 15.1, get care facility, not no, it is facility. I keep reading that weird. 15.6, standard IO.h 15.1, string constants 2.7.4, trigraphs 2.1.4. And there's one more chapter. Holy crap, we are slowly chipping through this. I don't know how, but we're doing it. We're all suffering together like one big happy messed up family. Reminds me of home. Anyways, now is a brief moment for anyone in chat to say anything if they want to. I'm going to take a quick drink to refresh myself, and then if not, then I will continue with the suffering. Imagine being like locked in like a POW camp and like showing like being like, you can leave, but like for you to exit you must read the entire C programming language manual. how many people do you think would like just give up at that point? Like just be completely like, nah, you done. You cook, chief. Oh my god, that'd be painful. Anyways. Let me check a quick thing or pull up a quick thing. There we are. Awesome. Yeah, I'll begin the next chapter. One more little nudge reminder is that you can use bang TTS at the start of your message in chat if you want to use it to start a TTS message, which I will then trigger at the end of the section. So, hey, say hi, Kib. Or not Kib, your name is Tib. I am very, very silly. Just gotta wait for Tib to catch on because they're a little bit stupid. It's okay because, you know, they'll catch on one of these days. Tib is just absolutely wonderful, you know, peak of engineering. They're just absolutely wonderful as a character. Pupper's still staring at me all weird. He's like, what the heck are you talking for? You shouldn't be talking like that. Oh.
Says, hi, Tid.
Hello, Tid. How's it going? Well, there's the bot working. I can see that they finally loaded and started working. So, yep, the latest ever. Well, I'm gonna set Tid to mute so that they don't try to be clever anymore. And hey, shall we carry on with more of the manual? I think we shall. 2.7.7 numeric escape codes. Numeric escape codes allow a character from the execution character set to be expressed by writing its coded value directly in octal or in standard C hexadecimal notation. Up to 3 octal or any number of hexadecimal digits may appear, but standard C prohibits values outside the range of unsigned char for normal character constants and values outside the range of wchar underscore t for wide character constraints. For instance, under the ASCII2 encoding, the character apostrophe A apostrophe may be written as apostrophe backslash 141 apostrophe or apostrophe backslash x61 apostrophe, and the character apostrophe question mark apostrophe, or sorry, apostrophe question mark apostrophe as apostrophe backslash 77 apostrophe or apostrophe backslash x3f apostrophe. The null character is used to terminate strings, is always written as backslash 0. The value of a numeric escape does not correspond to a character in the execution character set is implementation defined. Example. The following short code segments illustrates the use of numeric escape codes. The variable in char has type int. For left parenthesis, colon, right parenthesis, left squirrely bracket, in char equals receive left right parenthesis semicolon. If left parenthesis in char equals apostrophe backslash 0 apostrophe right parenthesis continue semicolon, comment begin ignore and comment. If left parenthesis in char equals apostrophe backslash 004 apostrophe right parenthesis break semicolon, comment begin quit comment end. If left parenthesis in char equals parenthesis apostrophe backslash 006 apostrophe right parenthesis reply left parenthesis apostrophe backslash 006 apostrophe right parenthesis semicolon begin comment ack end comment, else reply left parenthesis apostrophe backslash 025 apostrophe right parenthesis semicolon comment begin nak end comment right curly bracket. There are two reasons for the programmer to be cautious when using numeric escapes. First, of course, the use of numeric escapes may depend on the character encoding and therefore be non-portable. It is always better to hide escape codes in macro definitions so they are easy to change. Hashtag define NUL apostrophe backslash 0 apostrophe. Hashtag define EOT apostrophe backslash 004 apostrophe. Hashtag define ACK apostrophe backslash 006 apostrophe. Hashtag define NAK apostrophe backslash 025 apostrophe. Brief asterisk is with the previous abbreviations. Null, EOT, ACK, and NAK are all capitalized. Second, the syntax for numeric escapes is delicate. An octal escape code terminates when 3 octal digits have been used or when the first character, that is a non-octal digit, is encountered. Therefore, the string double quotes backslash 0111 double quotes consists of 2 characters, backslash 011 and 1. The string double quotes backslash 090 double quotes consists of 3 characters, backslash 0, comma, 9, comma, and 0. Hexadecimal escape sequences also offer from the termination problem specifically since they can be of any length. To stop the standard C hexadecimal escape in a string, break the string into pieces. Double quote, backslash, X ABC, double quote, comment begin. This string contains 1 character, and comment. Double quote, backslash, XAB, double quote, space, double quote, C, double quote, comment begin. This string contains 2 characters, end comment. I will add as an asterisk here, or amendum, or what have you, that when I say start comment, I am referring to / asterisk, and when I say end comment, I am referring to asterisk backslash. Just so there's no confusion of what I mean when I say that. Some non-standard C implementations provide hexadecimal escape sequences that, like octal escapes, permit only up to a fixed number of hexadecimal digits. References. Character constraint 2.7.3. Hashtag define 3.3. Macro definitions 3.3. Null character 2.1. String constant 2.7.4. Execution character set 2.1. Ooh, 2.8 C compatibility. Look at that fancy little thing we get to deal with. Isn't that wonderful? Well, I see this is where we begin suffering. Zizzity za. Well, at least these this little chapter seems to be short. Sure, that looks painful. Okay, I think what we'll do, just for those listening, is we'll make it to the exercises part right here in 210. We'll stop there, and then when we get to the exercises section, we will then partake in it next stream tomorrow night. 7 to 11 PST, often a little bit late, but not too much normally. wink, wink, nudge, nudge, about half an hour. That's not too late, right? Oh, also, friendly reminder, just because YouTuber generic BS, if you're enjoying the stream, hey, sub button, like button, algorithmic stuff, help a nerd out. make the dopamine centers of my brain go sparky when I see number go up. Anyways, this section lists the lexical differences between C and C++. 2.8.1 character sets. Whoops, need to highlight that. The token respellings and trigraphs in standard C are part of the C++ standard, but they're not common in pre-standard C++ implementations. Both C and C++ allow universal character names with the same syntax, but only C explicitly allows other implementations to define characters and identifiers. Left parenthesis, one exception that C++ implementations will provide them as an exception or extension. One expects that C++ implementations will provide them as an extension. There we go. 2.8.2 comments. C99 comments are acceptable as C++ and vice versa. Before C99, the characters // did not introduce a comment in standard C. And so the sequences of characters // star in C could be interpreted differently in C++. Left parenthesis, the details are left as an exercise. Right parenthesis. 2.8.3 operators. There are 3 new compound operators in C++. : dot asterisk dash right angled bracket asterisk ::. Since these combinations of tokens will be invalid in standard C programs, there is no impact on portability from C to C++. 2.8.4 identifiers and keywords. The identifiers list in table 2-8 are keywords in C++, but not C. However, the keyword wchar_t is reserved in standard C, and the keywords bool, true, false are reserved in C99 as part of the standard libraries. Table 2-8 additional C++ keywords. ASM, bool, catch, class, const_cast, I don't like the way I said that, delete, dynamic_cast, explicit, export, false, friend, mutable, namespace, new, operator, private, protected, public, reinterpret_cast, static_cast, template, this, throw, true, try, type ID, type name, using, virtual, wchar_t. 2.8.5 character constants. Single character constants have a type int in C, but have the type char in C++. Multi-character constants, which are implementation defined, have type int in both languages. In practice, this makes little difference since C++ character constants used in integral context are promoted to int under the usual conversions. However, size of left parenthesis apostrophe C apostrophe right parenthesis is size of left parenthesis char right parenthesis in C++, where it is size of left parenthesis int right parenthesis in C. 2.9 on character sets, repertoires and encodings. Sorry, on character sets, repertoires and encodings. That one threw me for a curve there for some reason. I don't know why. I apologize. The C language was originally designed at a time when the needs of international multilingual programming community were not well understood. the needs of. Standard C extends the C language to accommodate that community. This section is an informal overview of the history and problems to be addressed in Standard C to make the language more friendly to non-English users. Repertoires and ASCII2. ASC2. Every culture bases its written communication on a character repertoire of printable letters or symbols. For U.S. English, the repertoire consists of the usual 52 upper and lowercase letters, the decimal digits, and some punctuation characters. There are about 100 of these characters, and they were assigned particular binary values, left parenthesis, by U.S. English programmers and computer manufacturers, right parenthesis, using a 7-bit encoding known as ASCII2. ASC2. These encoding characters appeared on standard keyboards and found their way into such places as the C language definition. Unfortunately, other cultures have different repertoires. I don't know why I have such an issue with that word. Repertoires. Repertoires? Are different repertoires? How do I say this word? Why am I blanking on this? I'm gonna throw this into Google real quickly. I apologize. Because I feel like I'm saying the wrong word over and over and again, and I would rather correct myself before getting it wrong. Repertoire. Okay, it is a repertoire. Repertoire is an ANSI too. So wherever I said repertoires or whatever it was, repertoire. It's almost like the word has a French base and I'm an English speaker. Yay! For example, English speakers of the United Kingdom would rather have pound than $, the pound symbol than the $sign symbol, but 7-bit ANSI2 does not contain it. Languages such as Russian and Hebrew have entirely different alphabets, and Chinese, Japanese, Korean, left parentheses, CJK, right parentheses, cultures have... Frick, how do you say it again? Sorry. It's repertoires, isn't it? Yeah, repertoire. God, I don't know why that like if it had little asterisks, or not the asterisks, the a rise at the end, like the up to the right tick on the E, I'd be able to read it, but because it's like it doesn't have that, my brain is always just like, that's English. That's an English word. Shut up. Carrying on. Cultures have repertoires with thousands of symbols. Programmers today want to build C programs that read and write text in many languages, including their native ones. They also want to have native language comments and variable names in their programs. Programs so written to be portable in other cultures, at least to the extent of not being invalid. Left parenthesis, you will not be able to read a Sanskrit comment unless you understood Sanskrit, and your computer can display Sanskrit characters, right parenthesis. The full scope of this problem was only gradually realized, by which time several partial solutions had been devised and are still supported. For example, the ISO 646-1083 invariant code set was defined as a subset of ANSI2 that is a common way to cross many non-English character sets, and ways were invented to replace C characters, but not the similar set, including left curly bracket, comma, right curly bracket, comma, left square bracket, comma, right square bracket, and hashtag, pound, whatever you want to refer to it as. ISO-IEC, IC 1064-6. The general solution for character sets is defined by the ISO-IEC standard 1064-6. 10646, I'm just gonna say it like that, I think. Left parenthesis plus amendments, right parenthesis. Universal multi-octet coded character set, left parenthesis UCS, right parenthesis. This defines a 4-byte, left parenthesis, or 4-octet, right parenthesis, encoding UCS-4 that is capable of representing all characters in all earthly cultural repertoires with plenty of space left over. Repertoire. There is a useful 16-bit subset of UCS4 called the Basic Multilingual Plane, left parenthesis UCS-2, right parenthesis, which consists of those UCS4 encodings whose upper 2 bytes are 0. UCS-2 can represent all major cultural repertoires, including about 20,000 CJK ideograms. However, 16 bits are not quite enough in general, and no larger size, less than 32 bits, is convenient to manipulate on computers, which is why there is UCS4. This is word salad for my brain right now. The Unicode character set standard was originally a 16-bit encoding produced by the Unicode Consortium, left parenthesis www.unicode.org, right parenthesis. Unicode 3.0 is now officially fully compatible with ISO-IC 10646. Previous versions were compatible with only UCS-2. The Unicode website has a good technical introduction to the character encoding. The character set standards UCS-4, UCS-2, and Unicode are compatible with ANSI2. The 64-bit characters, whose high order 8 bits are all 0, are just the 8-bit extended ANSI2 characters, now called Latin-1. The original 7-bit ANSI2 characters, now called Basic Latin, are UCS-2 characters whose upper 9 bits are 0. Wide and multi-byte characters. Character representations larger than the traditional 8 bits are called wide characters. Unfortunately, the 8-bit, left parenthesis, or 7-bit, right parenthesis, character is not so easily eradicated. Many computers and legacy applications are based on 8-bit characters, and various schemes have been devised to represent larger character repertoires, and wide characters using sequences of 8 or 7-bit characters. These are called multi-byte encodings or multi-byte characters, whereas wide characters all use a fixed side representation. Multi-byte characters typically use 1 byte or for some characters, 2 bytes for others, and 3 for others, and so forth. One or more 8-bit characters are treated as, quote, escape, unquote, or, quote, shift, unquote, characters, which start multi-byte sequences. When I say quote unquote, I basically mean start of a double quote, end of a double quote. It flows a little bit better English wise. What we see today in standard C is a combination of techniques, ways to deal with the obvious ANSI2 variants, left parenthesis, trigraphs and digraphs, right parentheses, which deal with fully modern wide character with a fully modern wide character environment. Ways to deal with multi-byte character sequences during I/O, and most recently, a way to represent any cultural adapted C program to a portable fashion. Left parenthesis, universal characters and local specific characters and identifiers, right parenthesis. Universal character names. C99 introduces a notion that allow any UCS-2 or UCS-4 character to be specified in character constants, string constants, and identifiers. The syntax is universal character name \U hex-quad capital U hex-quad 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 hex digit hex digit. Or sorry, those are all hex dash digits. I apologize. 4 hex dash digits. Each hex dash quad is 4 hexadecimal digits, which can specify a 16-bit value. The values of the hex quads are specifically in ISO-IC 10646 as the 4-digit and 8-digit, quote, short identifiers, unquote. For universal characters, the character designated by \U NNNN is the same as the one designated by \U 0000 NNNN. Period. C does not permit universal character names whose short identifiers are less than A00A0 except for 0024 left parenthesis $, right parenthesis, 0040 left parenthesis @ symbol, right parenthesis, and 0060 left parenthesis grave symbol, right parenthesis, I believe also a die rise, I believe is what it's also referred to as, nor those short identifiers lies within, nor those whose short identifier lies within the range of D800 through DFFF. These are control characters, including delete, and characters reserved for UTF-16. The result of using token merging to create a universal character name is undefined. References. Identifier and universal character names 2.5. Token merging 3.3.9. Okay. We're stopping here. This is the wall. This is the end. We are ending on the exercises, which tomorrow we will touch on and then do dot stuff, because holy heck, this was a lot of manual reading, which I did not expect to be very awesome. So hey, because the end of the stream is ending soon, I will tell everybody present to hey, send a little message in the doobly-doo if you want to have a doobly-doo read. If not, then don't worry about it. But hey, a nice little hi, goodbye thing if you want. Assuming nobody does that, I'm just going to pretend that this is an outro. So what I will do is I will say, hey, thank you so much for tuning in. If you enjoyed the stream, give the little doobly-doo a like if you liked it. Dislike it if you dislike it. I'm not going to tell you what to do. But hey, consider a subslurb. It's free. It makes me feel good. Gives me a tiny bit of motivation for dealing with all this crap. For grinding through with the dyslexia, because holy crap, it is painful as heck. And yeah, nice and fun. So, with that being said, thank you everybody so much for watching. I hope you enjoyed the stream. And I'll be back tomorrow at approximately 7, give or take half an hour, to about whenever the stream feels like it's good to end. So, hey, thanks again, and I'll catch you all later, since I don't see any messages. So, oodly-two, catch you later. If you want to chat after the stream, Discord link somewhere. Find it, volbyte.com/links. There you go. Bye! Yes, I wish.